Welcome to Tech AI Brain, your advanced guide through the digital frontier. Created by IT Samurai Teacher, we transform complex technology into accessible knowledge. Our mission: democratizing tech education through clear, comprehensive tutorials on AI, machine learning, and emerging technologies. I'm Alpha, your host, trained to break down technical concepts with precision and clarity. Together, we'll explore the future of technology. And today, we're diving into the fascinating world of artificial intelligence, specifically looking at the fundamental building blocks of AI: data, algorithms, and models. So why are these topics so important? Because understanding them is key to harnessing the power of AI and using it effectively. They form the basis of how AI systems learn, adapt, and make decisions. But don't worry if you're not a tech expert. We'll break it all down for you using simple language and real-world examples. Now let's start with data, the lifeblood of any AI system. What kind of data do AI algorithms need to learn and grow? Well, there are three main types: structured, unstructured, and semi-structured. Structured data is like a neatly organized spreadsheet with rows and columns. Think of customer information in a database. Unstructured data is more free-form, like text documents or images. And semi-structured data falls somewhere in between, like a social media post with some tags and hashtags. Each type presents its own challenges and opportunities for AI to learn from. Once we have the data, how does the AI algorithm process it and extract meaningful information? Well, that's where machine learning comes in. Machine learning is a type of AI that enables systems to learn from data without being explicitly programmed. It's like teaching a child to ride a bike. You don't program the child's brain to balance and steer, but they learn how to do it through practice and feedback. Similarly, an AI algorithm can be trained on a massive amount of data to identify patterns and make predictions. But how does the algorithm actually learn? That's where training and testing come in. The algorithm is first trained on a large set of data, and then it's tested on new data to see how well it can generalize. If the algorithm makes mistakes, the training process is repeated until it can accurately process new data. It's like teaching a dog a new trick. You reward good behavior and correct bad behavior until the dog learns the trick. This process of training and testing is at the core of how AI systems learn and improve over time. Now that we've covered the basics of data and algorithms, let's talk about models. An AI model is essentially a computer program that has been trained on a specific task. Think of it like a student who graduates from a university with a degree in computer science. The student has gone through years of training and has acquired the knowledge and skills needed to solve problems in the field. Similarly, an AI model has been trained on a specific task and has learned to perform that task well. Some popular AI models include decision trees, support vector machines, and artificial neural networks. Each model has its strengths and weaknesses and is suited for different tasks. For example, decision trees are good at handling both numerical and categorical data, while artificial neural networks are particularly good at handling unstructured data like text or images. When choosing a model, it's important to consider the specific task and the type of data that needs to be processed. Once trained, these models can be used to make predictions or decisions on new data. They become the basis for AI-powered applications and services that we use every day. For example, a trained image recognition model can be used to develop a service that automatically identifies objects in images. By understanding the different types of AI models and how they work, we can develop more effective and accurate AI-powered solutions. To put these concepts into perspective, let's look at some real-world examples of AI systems. One great example is Google's DeepMind AlphaGo system, which defeated a human champion at the complex board game. This system used a deep reinforcement learning algorithm to learn how to play the game from millions of human games. Another impressive example is IBM's Watson system, which defeated human champions at the quiz show Jeopardy! Watson used a combination of natural language processing and machine learning to understand the meaning of questions and find the best answers. These examples showcase the power of AI and the amazing things that can be accomplished when data, algorithms, and models work together. But it's not all sunshine and roses in the world of AI. There are some common challenges and limitations that we need to be aware of. One major concern is bias. AI systems can inherit and even amplify the biases present in the training data. This can lead to unfair or discriminatory outcomes, which is something we want to avoid. For example, if an AI system is trained on data that reflects gender stereotypes, it may perpetuate those stereotypes rather than challenging them. Another challenge is the black box problem. Some AI algorithms are so complex that it's difficult to understand how they arrive at a particular output. This lack of transparency can make it hard to trust AI systems, especially in high-stakes situations. For example, if an AI system is used to decide whether to grant a loan, it's important to understand how the system makes its decision. Despite these challenges, AI is still one of the most exciting and rapidly developing fields in technology. There are some incredible things on the horizon that we can look forward to. One exciting development is the rise of explainable AI or XAI. XAI aims to develop AI systems that are not only accurate and efficient, but also transparent and understandable to humans. Another exciting development is the increasing use of AI for good. AI is being used to develop new treatments for diseases, to protect endangered species, and to help solve other important problems facing humanity. By understanding the fundamental building blocks of AI, we can better harness its power and ensure that it's used responsibly and ethically. Now that we've covered the key concepts of AI, let's take a moment to recap what we've learned. AI, or artificial intelligence, is a branch of computer science that deals with the simulation of intelligent behavior in computers. At the core of AIs are data, algorithms, and models. Data is the raw material that AI algorithms learn from. Different types of data present different challenges and opportunities for AI to learn. We've explored three main types of data: structured, unstructured, and semi-structured. Structured data is stored in a tabular format with rows and columns, while unstructured data is in a more free form, such as text or images. Semi-structured data falls in between, containing some structure but also some unstructured components. Each type requires different techniques for processing and analysis. Understanding the characteristics of each data type is crucial for building effective AI systems. Next, we've looked at algorithms, which are the step-by-step procedures that process the data to extract meaningful information. Machine learning is a popular type of algorithm that enables systems to learn from data without explicit programming. It works by training the algorithm on a massive amount of data and then testing it on new data to see how well it can generalize. The training process involves adjusting the algorithm's parameters to minimize the difference between its predictions and the actual values. This iterative process continues until the algorithm can accurately process new data. Finally, we've considered models, which are the output of the training process. An AI model is essentially a computer program that has been trained to perform a specific task. Popular models include decision trees, support vector machines, and artificial neural networks. Each model has its strengths and weaknesses and is suited for different tasks and data types. Choosing the right model is critical for developing effective AI-powered applications. We've also discussed some real-world examples of AI systems, such as Google's DeepMind AlphaGo and IBM's Watson, showcasing the incredible things that can be accomplished with AI. However, we've also acknowledged the challenges and limitations of AI, including bias and the black box problem. As AI continues to develop, it's important to address these issues to ensure responsible and ethical use. One promising area of research is Explainable AI or XAI, which aims to develop AI systems that are not only accurate, but also transparent and understandable to humans. Another exciting development is the increasing use of AI for good, such as in healthcare, conservation, and other important fields. Overall, AI is a rapidly evolving field with enormous potential to transform our world. By understanding the fundamental building blocks of AI, we can better harness its power and shape its future development. Now it's time to hear from you. What are your thoughts on the role of data, algorithms, and models in AI? Do you have any questions or comments? Leave them below. Don't forget to subscribe for more updates on the latest tech trends on Tech AI Brain created by IT Samurai Teacher. Thanks for watching, and we'll see you next time.